Assalamualaikum. Good evening to all the panels. We are from Group 6. My name are Noor, Nabila Mazlan, Syazani, Syazwan, Latip, Athirah. I will do a presentation of production of 20,000 metric ton per annum Pentaerythritol. So this is our presentation's outline. Okay, for process improvement, we add additional pump to each of the raw material inlets. We remove the heater before entering the evaporator. Next, we add additional evaporative crystallizer and centrifuge separator for recycling the mother liquor. Next, and then we remove the heater before entering the dryer. Next.
So now we will explain on the heat integration. These are the details of streams for heat integration. Initially, we have 3 hot streams and 2 cold streams. First round of heat integration, we decided to consider only H2, H3, and C1 streams in our process heat integration. Meanwhile, H1 and C2 were eliminated. Why the elimination was made was because H1 and C2 are outliers. H1 has largest enthalpy, while C2 has smallest enthalpy compared to the other streams. Other reasons of elimination is that all streams are highly imbalance supplies and H1 and C2 streams have exceeded the minimum temperature approach. So this algorithm is to identify the heat surplus deficit for the selected stream. Since the process balance heat supply and heat demand, the integration can be considered as feasible. So this diagram shows the heat. Based on the physical cascade, the pinch point occurs at 97.5 degrees C, where falls 0 cumulative heat flows. After algorithm and heat cascading were conducted, the heat exchanger network is designed as shown in this figure. For the involved streams, there are 2 heat exchangers required and 2 coolers. For H1 and C, both need cooler and heater respectively. This table shows the comparison of utilities before and after heat integration. Before heat integration, the number of heater is 2 and the number of cooler is 3. And after heat integration, the number of heater is 1 and the number of cooler is 3, with additional 2 heat exchanger. So this shows table of percentage of energy saving. In the table, it shows which stream's energy saving has higher than selected stream matching. However, the reverse heat integration is more feasible than the previous heat integration. And this diagram shows our diagram after heat integration being conducted.
So now I will continue for the process optimization for cooling crystallizer. So next, the objective function for this optimization is to maximize the saving of utility costs and also to get the desired crystallization yield. The variable will be the operating temperature of the crystallizer, and the range is set between 15 to 30 degrees Celsius. Next, this graph visualizes the contradicting trends of utility cost saving as well as the crystallization yield. From the graph, we can obtain 2 different linear equations as you all can see here. Once the functions are obtained, optimization is performed through Lingo version 18 to get the optimal value for the operating temperature. So next, the left figure illustrated the optimization coding in Lingo version 18, while the right figure shows the result obtained after the optimization. Next. So in conclusion, the optimal operating temperature is around 22.52 degrees Celsius, and at this particular point, we can save up to around 79 ringgit and 80 cents per day, with 90.10511% of crystallization yield. Next.
Now I'm going to explain the sizing and costing for all equipment in our plant. Next. Firstly, the volume for mixer is 4.67 meter cube, while the cost is 331,000 ringgit. Next. The total costing for stream pump is around 500,000 ringgit. Next. For the total costing heat exchanger is 89,000 ringgit. Next. The cost for heater is 4,000 ringgit. Next. The total costing for cooler is 292,000 ringgit. Next. The volume of the reactor is 73.8 meter cube with internal diameter of 3.15 meter. The costing for reactor is 2.38 million ringgit. Next. The volume for neutralization tank is 5.7 meter cube with internal diameter of 1.34 meter. The costing for neutralization tank is 476,000 ringgit. Next. The costing for evaporator is 5.9 million ringgit. Next. The volume for cooling crystallizer is 34.8 meter cube, while for evaporative crystallizer is 12.8 meter cube. The costing for cooling crystallizer is 1.4 million ringgit, while for evaporative crystallizer is 3 million ringgit. Next. The total costing for centrifuge is around 3 million ringgit. Next. The volume for dryer is 31.89 meter cube with internal diameter of 1.7 meter, and the costing for dryer is 4.8 million ringgit. Next. Lastly, this table shows the total costing for all equipment, which is 23.5 million ringgit. Next.
So now I will explain on the mechanical design. This diagram shows the structure of available industrial falling film type evaporator. In current industry, the typical falling film type evaporator has two vessels for two main processes. The first vessel is for heating chamber and the second vessel is for separating chamber. And this table shows the designation and specification data for evaporator. This table summarizes the specification data, operating data, mechanical design data, and design sizing data. And for design sizing data, we considered tube shape, shell, cylindrical vessel, base ring, ball hole, skirting, and baffle. And this diagram shows overall designation of vertical falling film evaporator. The innovation from the available evaporator is that our evaporator only requires one vessel for two main processes. The heating process occurs in the shell and tube part, and the evaporation process occurs in the bottom part of the vessel. The vapor, which is formaldehyde, will evaporate out through outlet 1, and the concentrated liquid will proceed to outlet 2. So this diagram shows the designations for skirt and base ring. It functions as the column support for our vessel. And this diagram shows the designation for tube sheet and baffle. This tube sheet designed with triangular pitch with 1-inch pitch, and for the baffle designation with segmental baffle cut with 25% baffle cut and with baffle and shell diameter clearance at 1/8 millimeter.
Now I'm going to explain the waste treatment plant. Next. The waste generated from our plant is from stream 16 and stream 23. Stream 16 contains formaldehyde, which is a chemical substance that is harmful when discharged to the environment. Meanwhile, stream 23 contains sodium formate, and the chemical is biodegradable. The waste generated needs to be compliant with the environmental act before being discharged to the environment. Formaldehyde is extremely toxic even in very small concentration, and it will cause negative impact on the performance of the activated sludge system. That formaldehyde needs to be treated, and the method that we use to treat formaldehyde is by adding sodium sulfide. It will convert formaldehyde to sodium formaldehyde bisulfite, and it is non-toxic to livings, and it is biodegradable substances. Next. Next. Okay. This is our wastewater treatment plant. It consists of 3 treatments in series, which are primary, and secondary treatment. Firstly, wastewater undergoes pre-treatment. It is first sent to grid chamber to remove solid particles from the wastewater. Then wastewater will undergo oxidation reaction to treat formaldehyde. After that, wastewater undergo primary treatment. Wastewater undergoes fluctuation process, which the accumulation of destabilized particles into a large sized particles known as floc occur and remove it by sedimentation or flotation. After that, wastewater undergoes secondary treatment, which is a biological treatment and where the activated such process occur. It is to remove most of the fine suspended and dissolved degradable organic matter that remain after primary treatment so that the effluent is suitable for discharge. Before effluent being discharged to the river, it will undergo disinfection to kill pathogen and bacteria. Lastly, the sludge collected from sedimentation process will be acclimated at sludge holding tank. After a period of time, the sludge is sent to the filter press to remove excess water before disposed to the landfill. Next.
Okay, for process controlling, we're controlling the temperature, the pressure, the level, and other controlling system by additions of the indicator, alarm, transmitter, and others. So the first one is mixer, where we control the flow rate, fresh feed, and also the level of the mixer. Next. For pump, we control the outlet pressure. Next. For heat exchanger, we control the temperature of the outlet stream. Next. For heater, we control the level and the temperature. Next. For cooler, we control the temperature and the level of the stream. Next. For setiap reactor, we control the temperature, the pressure, and the level inside the reactor. Next. For neutralizer tank, we control the ratio flow rate feed into the neutralizer tank and the temperature, the level, and the pressure inside the neutralizer tank. Next. For evaporator, we control the temperature of the outlet stream, and we control the pressure and the temperature inside the evaporator. Next. For cooling crystallizer, we control the pressure, the temperature, and the level of the cooling crystallizer. Next. For evaporative crystallizer, we control the pressure, the temperature, and the level at desired point. Next. For centrifuge separator, we control the centrifuge, maintain the level of the centrifuge separator at the desired point. And the last one is dryer, where we control the pressure and the temperature of the dryer. Next.
So now I will continue for the process safety strategies and study. Next. So I divided this part into 4 different parts, which are general safety, emergency response, hazard study, and also plant startup and shutdown. So the general safety included personal protective equipment and first aid, chemical handling, on-site and off-site consideration. So before entering the plant, all the workers are needed to equip themselves with personal protective equipment in order to protect themselves against particular hazards of the working environment. First aid also play an important role in providing emergency treatment to those who injured before the arrival of professional medical assistance. In order to minimize the risk of happening accidents, all the workers should strictly obey the regulation when it comes to the chemical handling. On-site and off-site consideration are also important to minimize the possibility of public harm during any fire and explosion event, and also to protect the worker. For emergency response, it included the fire detection and alarm system, site emergency plan, and also the emergency operation center. Fire detection and alarm system is designed to discover the fire in their early state, where emergency action can be taken to minimize the loss. For site emergency plan, it should be attached in various visible areas in order to allow smooth evacuation process during any emergency incident. For the emergency operation center, it is an area for decision maker to gather critical information, to make discussion, to coordinate effective and immediate action when facing the emergency situation. For hazard and operability study, it is a formal procedure to identify potential hazard in the chemical process facility. This study includes the identification of parameters, analyzing causes, consequences, and also possible actions. The last one will be the plant startup and shutdown procedures. Plant startup and shutdown are important processes in the chemical plant operation, as hazardous materials may emerge during these two processes. Therefore, a specific operating procedure should be provided, and this procedure must be safe, easy, and flexible to carry out. Next.
Now I will explain on the heads-up study for CSTR reactor. So process parameters reaction, the deviation expected is no reaction due to low temperature, lead to no reaction. So the action is to install temperature control system. For more reaction, this is due to high temperature and pressure and lead to accumulation of reactant and product in the reactor. So the action required is to install temperature and pressure control system. And for the less reaction, this is due to purity of catalyst, lead to less purity and volume of the product, and we install temperature and flow control system. And for the process parameter feed flow, the deviation expected is no flow due to pipeline choke, lead to no product. So the action required is by installing flow indicator. And for more flow and less flow, the action required is to install flow and pressure controller and also install leakage and blockage indicator. So for process parameters backflow, this is due to failure on process controller. So we decided to insert for feed and pressure sensor controller. So for temperature, for high temperature and less temperature, we decided to install temperature and pressure controller and also having regular inspection on the equipment. And for the high pressure, for the causes is high temperature on the reactor. This is lead to explosion and rupture of reactor. So the action required is to install relief valve. For less pressure, this is due to low temperature and lead to poor reaction. So we install pressure sensor, controller, and alarm system. And for agitator, the deviation expected is no agitation, less agitation, and more agitation. So the action required is by having regular inspection on the motor and proper lubrication on motor.
Now I'm going to explain the heads-up for evaporative crystallizer. The first parameter is outlet flow. The deviation are no or low flow. The action required are install high-level alarm or install flow indicator and controller or do regular maintenance. Another deviation is high flow, and the action required are install low-level alarm or install flow controller and indicator, or replace the vent valve with a new one or repair it. Next. The second parameter is the temperature, and the deviation are low and high temperature. The action required for low temperature are install temperature controller and indicator or install low temperature alarm or do regular maintenance. Meanwhile, for high temperature, the action required are install temperature controller and indicator or install high temperature alarm or do regular maintenance. The third parameter is pressure, and the deviation is high pressure. The action required is install pressure controller and indicator or install high pressure alarm or replace the vent valve with a new one or repair it. Next, the last parameter is agitation. The deviation are no, low, or high agitation. The action required for all the parameters are the same. That is interlock with the feed line or do regular inspection and maintenance. Next.
Okay, so now I will continue for the last part of the presentation, which is the profitability analysis for our plant. Next. As you all can see in this slide, I summarized this analysis into some key points. The first one is the total capital investment cost. The TCI for our plant is around 182 million ringgit, and the capital investment cost included grassroots capital, direct and indirect costs, working capital, and also startup costs. And the annual total expenses for our plant is around 128 million ringgit, which included the total production cost and also the depreciation value. Pump utilities and heating cooling utilities are included in the annual utility cost, and the total cost is around 8.4 million ringgit. From the sales of our main product, we can get a total of around 149 million ringgit of revenue, and the annual profit after the deduction of the income tax is around 13.7 million ringgit. We also calculated the annual after-tax rate of return, and the rate is around 15.87%. Based on the analysis, the undiscounted payback period is around 6.56 operating years after 3 years of startup and also the construction period. This means that our plant will start earning after the payback period of 6.56 operating years. Lastly, the maximum allowable performance discount rate for our plant is around 12.7847% with a net present value of 0 after 20 years of operation. So in conclusion, this project is feasible to carry out. So that's all for our presentation. Thank you.
Okay, thank you very much. Well done for presenting the final presentation. Okay, the panels, maybe Dr. Noor can start first.
Okay. Habis sebelum tu tanya dulu, Lim dia ada kat mana? Kat sekolah.
Lim, where are you?
Lim, where are you?
UTN.
Where are you?
In UTN.
Oh, UTM. Tu nampak macam ada kat sekolah. Tu nampak macam background kenal.
Saya masih di sekolah. Saya tunggu semester ini habis baru balik.
Oh, you tak balik lagi
Tak, saya dari Penang. So saya tunggu habis SEM, habis final exam saya baru balik.
Oh, baguslah awak. Okay. Okay. Yang first kali in term of basic you lah in term of unit lah So dalam semua you punya slide tu, if you check your unit not consistent, some slide ada in feet, meter, inch, macam-macam unit ada mixed unit, so please consistent. Okay.
Okay, sure.
Okay, so many semua you betul lah.
Okay, boleh.
So cuma yang lain tu mungkin bagi orang lain lah. Crystallizer you. Crystallizer. Okay. Stream 28 tu. Then after crystallizer you ada dryer kan?
Yes.
Tapi stream you tu masih dah 120 degrees C, still contain water, right?
Oh.
Stream.
So you dry at 120 degrees C at 1 atm. Kalau based on basicnya, maknanya all the water remove
Yeah.
And then why ada lagi masih ada water itu?
Actually this one, okay, after we undergo the drying process, right? Majority of the water will be evaporated out, and that's the product, right? And the product are with some minor waters, right, on the product.
Kenapa? Because at 1 atm you supposed to have 30 because you not a hydrated crystal. You ni solid crystal biasa. Kenapa still ada water?
Okay, so the first one is based on the first one is based on the what we call the when we use the software
Hassim
Hassim, when we undergo the process in the software it also show that there is some little water also on the crystallizer, and based on the journal we read, there's also some impurity water on the products when after drying process occur. So this one the percentage of the water on the crystallizer, right, is based on the journal we read. Then we take the percentage of the impurity after the drying, then we calculate it.
Is this your water is your impurities? Maksudnya macam tu?
Yeah, water is one of the impurity, yeah.
Okay.
Yeah.
And you can justify lah because you would for dryer 130 at 1 atm should be all the water removed.
Yeah, should be.
So you can justify water dekat you punya crystal tu is impurities.
Okay, sure. Okay, thank you.
And then yang lain dulu lah, itu yang PFD dah so ada some improvement, okay. The next,
Okay, Dr. Sarudin, Dr. Hassim.
Okay, boleh dengar tak?
Boleh, Doktor.
Okay. Saya nak tanya berkaitan dengan, your payback period is 6.5 years kan? 6.5 years out of 15 ke 20? Your life?
Oh, the operation life is 20 years.
20 years, okay. Graph yang you plot, net present value lawan versus years tu, ada tak? Graphical punya. Graph ada pula tak?
I ada graph tapi yang net present value against what?
Dia yang ada zero interest, kemudian yang ada interest tu. Ada tak?
Ada.
Can you show me the graph?
Can.
Okay.
So I stop share.
Boleh. Doktor nampak tak?
Okay. Yang ni, yang ada interest ke tak ada? Without interest?
Ni tak ada.
Tak ada. Okay, yang ada interest?
Yang ada interest ini.
Tak ada. Ya, ada plot. Oh, okay, ada plot
Ya.
Okay. Tax rate berapa you consider dalam your calculation? Tax rate?
Tax rate untuk apa? Income tax.
Ya, income tax.
Income tax I ambil agak-agak je I ambil 35%.
35. Okay. Tapi biasanya around 25, 26 macam tu lah. Tapi it's okay lah.
Okay.
Based on your assumption kan?
Ya, assumption.
Okay, alright. So itu je lah saya nak tanya.
Okay, terima kasih doktor.
Okay.
Dr. Sarudin, nak tanya apa?
Kejap. Saya nak tanya dengan yang you share dalam email tu.
Yes.
Alright. Boleh stop sharing lah. I nak share sekejap.
Okay.
Okay. Satu part yang dekat sizing and costing tu, yang ni, I dah lupa sebenarnya. Boleh explain tak? Macam mana how you calculate this bare module cost for your pump? Because it based on what? Because yang I compare this to P102 and 104, nampak kan?
Nampak.
Okay. Satu flow rate dia for only 4 gallon per minute. The other one is 92. But yang 4 gallon per minute tu paling high the most expensive lah.
Yes.
Kenapa
Sebab dia punya pump efficiency tu yang P102 tu rendah. Jadi dia effect dia punya harga.
So maksudnya pump 0.034 efficiency tu lagi
sebab flow rate dia kan rendah. So
so efficiency tu lagi tak bagus ke lagi bagus tu?
Tak bagus.
So tak bagus lagi mahal I just confused je. Tak mahal tak bagus lagi mahal
Oh, tak bagus lagi mahal. Bagus lah. Beli yang bagus. Lagi murah.
Saya confused betul tak betul ni?
This is spot on, Dr. Sarudin, to discover this error.
So, okay lah, you check balik lah.
Nanya, Dr. Sarudin, jangan beralih. I want to comment again also on this one.
Okay.
When you refer to purchase any pump, centrifugal pump, did you refer to any curve fitting chart?
No.
So how do you decide on purchasing or selecting the pump?
Berdasarkan buku teks yang PD tu.
Okay. Noted. Actually, in reality, when you want to purchase a pump, okay, now this is your level at the moment, you refer to the textbook. But in reality, when you are working as an engineer, you will actually refer to the pump curve fitting, okay, where there will be the head loss, the flow rate, the kilowatt or horsepower, the impeller size, diameter dan sebagainya lah. Okay, there are many things. And then most importantly, the flow rate there, which is like, for example, P100, 26.0533, itu terlalu sangat detail lah. Maksudnya, you don't have to put it until that 4 significant figures for the flow rate. You are not going to get such precise flow rate like that, correct?
Yes.
So you letak 26 gallon per minute ke apa ke macam tu, okay lah. Ini P101 54.6477 is too specific, and you will never find such number inside the pump calibration curve. Alright. So this is, but then most importantly, what Dr. Saharuddin just now discovered and mentioned, highlighted to you, it's very unlogical that you have such price like that. Okay?
Kot. Sebab calculation ni kalau tengok pump efficiency dia 0.0034 means what apa? No efficiency.
Maybe the utilities use include in the there.
Okay, this is very important for you to refer back to the pump calibration curve. Of course, inside the pump calibration curve pun ada efficiency. Alright, I know you guys are not at the level yet at the moment, but then when you put the numbers there, you also need to think logically as well. Maksudnya, this is something that definitely you need to rectify. We cannot accept such figure like this. Okay, dah lah slow. Flow rate dia slow, capacity dia pun tak besar. It's not due to the efficiency that you can actually, you are blaming the efficiency, and then as a result your cost is that high. So it doesn't work that way. Okay, so please rectify this. Okay, Dr. Saharuddin, you can continue.
Okay, next part. Next part kalau share ni nampak tak? Nampak tak?
Nampak. Setelah itu.
Nampak ini pasal PNID. Ia punya control on the yang ni CFTR
Yes.
Crystallizer.
No. Crystallizer.
Oh, crystallizer. Okay, crystallizer. Yang loop 191 tu. Loop 191 tu, so I circle tu, you measure yang mana You measure temperature dekat mana?
Oh, actually, your answers. Nabila nak answer tak?
That one ada temperature inside the crystallizer.
So should be inside lah. Nampak macam you measure dekat jacket je.
Oh no.
Dengan sebab I tengok you punya hot steam in tu terus masuk dalam tank.
Oh.
Right. You punya arrow tu masuk dalam tank. Suppose dia kat dalam jacket saja. Kan? So mungkin ada error on drawing lah. Right? Okay. So you betulkan balik.
Okay.
Yeah.
Error on drawing tu 101 dengan V3. You check juga. You punya screen tu itu kan motor punya tu kan. Boleh you buka PSD you. Dekat V101 dengan 103. Sekejap. Lah.
Okay.
Lepas ni kita buka PID
Okay.
Okay, next part yang ni yang ni you share juga yang nampak yang ni
Nampak.
Okay, yang ni you punya R100. You nak control temperature, right? Temperature inside R100 kan?
Yes.
Tapi you manipulate flow in temperature ke? You manipulate flow in punya apa? Suppose you manipulate cooling water kan? Cooling water tu tak ada apa-apa kat situ.
Cooling water.
Bukan you screen you manipulate, right?
Supposedly yes.
Suppose yang ini kan, yang cooling water, right? Suppose you control valve dekat cooling water tu lah, cooling water in, right? Okay. So you boleh share yang PFD
PFD.
Doktor.
Yeah.
Maksudnya yang buff tu dekat stream dekat cooling tu ke?
Ya, dekat cooling water sebab kita nak manipulate yang cooling water kan. Okay.
Temperature cooling water. Dr. Nur Ashikin tadi nak pergi tengok PFD. PFD.
Frame nama berapa dia tak ingat?
Tengah sikit nak tengok apa tadi? Pump punya PIC ke?
Bukan tengok PID awak. Tak, saya saja salah group ni. Sekejap. Aku buka bagi awak tu. Saya pun dah pening ni. Apa file dia pun tak komisen.
Yang B.
Awak buka tengok betul ke? Awak punya ke guru lain punya?
Nombor berapa tu, Doktor?
Sekejap. Mana? Awak dah buka ke?
Dah.
Okey, kejap Guru awak ke? Kenapa? Guru lain kejap. Okey, guru lain.
Okay.
Orang lain.
Okay, tak apa. Okay, terima kasih, Doktor.
Okay, Doktor.
Tapi
Dr. Sarudi, Dr. Hashim ada lagi tak nak tanya?
Saya tak. Tak ada.
Dah habis. Okay.
The corrections, the comments, please make corrections, okay? Saya ada satu soalan dekat you punya mechanical engineering drawing. Mechanical engineering drawing?
This one? Which one?
Laki.
Yes, what? You want to ask?
Sekejap. Sebelum laki pergi.
Okay.
Tadi. Bukan tadi. Betul lah yang ni awak punya drawing tu. Okey tadi. Ya, sikit je nak betul kan. Awak tengok V103 dengan V101.
V10.
And V103. 3 kan?
Okay.
Itu adalah motor setera kan? Itu motor kan? Macam mana keluar string keluar ke motor?
okay. Okay.
String tak boleh lalu motor.
Ya.
Ada ke string keluar ke motor, okay?
Okay,
Doktor. Thank you.
thank you, Doktor.
Okay.
Saya lupa nak tanya apa.
Teruskan. Ingatkan terus.
Okay. Dekat
Design.
ini soalan yang taklah penting sangat tapi saja nak tanyalah. Dekat mechanical engineering drawing tadi, you ada mention skirting tu. Okay. Mana gambar skirting?
This one.
Bukan lagi satu. Oh, ni skirting kan?
Ni tip.
Okay.
Ni
So, saya punya soalan adalah, sekejap, ini untuk alat apa ni? You punya what equipment?
column support.
Okay, column support kan? For your support kan? Do you actually have kaki untuk your column ataupun you solely depending on your skirt? Maksudnya ada support macam kaki ataupun you depend totally on your support. On your skirting.
From this diagram, we totally depending on the skirting. Yes. Skirting and bashing.
So adakah sufficient untuk support the column? That's the first question. The second question is, should you have an exit or outlet valve at the bottom of your column?
Sorry, Doktor. Should.
Maksudnya perlu ada tak satu valve, drain valve? So sekarang saya tengok dia tak ada drain valve dekat dia punya shell outlet nozzle tu. Itu patutnya ada ke ataupun tak ada ke atau macam mana?
So far yang saya tengok from industrial definitions of evaporator, tak ada drain valve lah. Yang ada shell inlet, shell outlet and yang outlet untuk vapor and outlet untuk concentrated valve lah. Yang drain tu saya tak jumpa lagi.
Okay, so tak perlu ada lah kot
Yes.
Okay, tak apa saja nak tanya. Alright, itu je. Apa lagi? Panel lain?
Tak ada.
Tak ada.
Tak ada.
Okay, rasanya itu saja. Thank you very much guys. Well done for the presentation. I must compliment you guys on your hands-on. Your hands-on is very detailed. So mungkin pasal ada your supervisor lah kot yang mengecek kan.